name is Thomas George, and this is Lessons from Crashes, a presentation about automotive accidents in the United States. So, why did I pick this? Well, the United States suffers about 40,000 traffic deaths a year, which is more than a bunch of other causes that get way more news attention. And perhaps what's even more troubling than that is that automotive accidents are actually increasing in the United States as compared to a lot of other causes which are decreasing. So, because of this, I chose this as my presentation to figure out what possible reasons cause these accidents and what public policy steps could be taken to perhaps reduce the overall fatality rate. So, I had to get some data sets. My first data set, my CSV data set, is entitled vehicles.csv, and it shows vehicle data and accident data for accidents in the United States. And I chose it because it was representative of the whole country, and that allows me to make conclusions about public policy for the country writ large. Cleaning from this was relatively simple. I removed a lot of the entries that had null values in key fields that I wasn't able to fill in with anything, and I also formatted it in a way that I could merge it with my other data sets. My second data set was my HTML data set, and this data set showed the different accidents for each state in the USA. And the reason I chose this is because the vehicles data set, my previous one, which I was kind of using as my main one, did not break down the collisions by type or state like this does. So this is kind of a nice supplemental data set to complement the main one. Perhaps the main cleaning thing I did in this data set was I combined the states into regions because the vehicles data set only had data in regions. So if I was going to accurately compare them, I needed to transform this one. And my third and final data set was my API data set, and it showed vehicle specifications for every motor vehicle in the United States. And I chose it because it had a lot of information about vehicle safety systems that was not present in the vehicles.csv dataset. And cleaning, not too much cleaning, but data access was a little difficult because essentially there was a different API for each vehicle type, so I had to do a for loop and call a new API for each vehicle mentioned in the vehicles.csv dataset, as you can see below. So, with all those data sets, I made some insights. The first thing I wanted to do, though, was make sure my data was representative. I know I said previously that the first vehicles.csv dataset was representative. It said it was, but I think it's very important when ensuring data quality to ensure that it actually was representative. So what I did is I figured out what percent of the sample was in each region and compared it to my second data set, which had the true percentages, to figure out whether it was representative. And as we can see here, most of the percentages are relatively close. And, certainly nothing that would make me believe that it was not representative. All right. And then for my second insight, perhaps my most important one, I found the number of accidents and number of fatalities for each hour in the data set. And of course, that's military time on the right. So I have some key conclusions here, but I think the easiest way to do it is to look at the visual I made. So this visual shows the accidents in the red line and the fatality rate in the blue columns in the background. Now, unsurprisingly, accidents were higher during the day and fatality rate higher during the night. But even beyond that, I think that there was some interesting conclusions you could make. For one thing, you can see relative maxima in accidents during rush hour, both morning and late afternoon, as well as relative minima in fatality rate. Essentially, my reasoning behind this is that during rush hour, everybody's going slower. So while there are more cars causing more accidents, the type of accidents are usually a lot safer. And there are some other things you can take away from this data set, but for the sake of time, that's all I'm going to say for right now. My next insight was about whether alcohol increased levels of speeding. Probably my original thought was that it would, that alcohol would increase the amount of increase the level average speeding for each accident, but it actually didn't. The average speeding amount without alcohol was actually about 0.6 miles per hour more. So that was pretty surprising. But my important public policy takeaway from this is that speeding shouldn't be used as evidence for a DUI because speeding didn't have any correlation with alcohol. My fourth insight was about safety features in cars, because a lot of new cars nowadays have a lot of safety features, but I don't know, I never really knew how much each of them made a difference. In this insight, I tested 3 different warning systems, often installed on cars, to see whether each of them lessen the severities of car accidents. And as you can see at the bottom there, all 3 of them, the forward collision warning, the blind spot warning, and the brake warning, all decreased the percent of crashes with a fatality. Some of them significantly. I mean, 0.25% of crashes, or there's between all vehicles and forward collision warning, that's 0.25% less fatal crashes, which might not sound like a lot, but I think if you're looking at 40,000 crashes nationally a year, I mean, that you're talking about hundreds of people that could be saved if forward collision warning is implemented on all vehicles. So I think that that's one public policy goal that I think could absolutely help with the issue. And for my final insight, I tried to find the correlation between speeding amount, so amount over the speed limit, and then the maximum vehicle speed. Because I've seen this theory that cars with higher maximum speeds have people that speed more, not because they are reaching the maximum speed, but because they feel like they should. They feel like they should speed more because the position of the gas gauge. They want to get closer to the middle of the lowest and the highest. And so a lot of people have theorized that. And because of that theory, a lot of people have said, okay, we need to lower the maximum speed on these vehicles and say, okay, we're not going to let people go more than 100 miles an hour or 110 miles an hour. However, if you look at the correlation between the speeding amount and the maximum vehicle speed, it doesn't seem as if there's any correlation at all. And I guess it's technically possible for there to be causation without correlation, but that's very unlikely. And so, yeah, it seems like there should not be stricter speed controls, at least not for the sake of improving public safety. And so a visual to go along with this was the scatter plot with the line of best fit. As you can see here, completely horizontal line of best fit. I mean, just no relationship at all. And then for my final visual, which was independent of any of my insights, I found the percent of all cases by location, and the percent of fatal cases by location. So for all cases, it was there are a lot of things that happen during intersections, a lot of accidents during intersections, whether it be four-way intersections or T intersections. But for fatal crashes, almost all things are not on intersections. So think about this on open road or on highways or whatnot. So this kind of goes to show that if you are trying to prioritize decreasing fatalities, you should focus on highways. Whereas if you're trying to focus on preventing vehicle damage, you also should probably focus on intersections, at least more so. All right, and then some conclusions. So what can be gathered about traffic accidents? So some conclusions I had were that there absolutely are ways to decrease traffic fatalities in the U.S. One of them was that one of the things I mentioned earlier was that traffic fatality rates are higher at night. Well, what if we increase the amount of EMTs at night? Additionally, we mentioned the safety features. If we make those mandatory, that absolutely can make things safer. So the problem of traffic fatalities in the U.S. is not intractable at all. We just need to have the willpower to go through with the reforms necessary to improve. And then on a personal level, what I learned personally from working on this project was several new things in existing modules, such as how to compute correlation in pandas or how to handle multiple graphs in Plotly. All right, well, that's the end of my presentation. Thank you for listening.